Good teaching. 4. Did it start yet? Am I huffing and puffing? I digress. All right. You guys do B and C. B is in radians, C is in what? Degrees. So for B, write the equation of cosine function with amplitude of 0.5. So we can go y equals 0.5 cos. B value, the period is 4 pi. So I can go B equals 2 pi divided by 4 pi, which is a half. Does that make sense for B to be a half and my period to double? Does that make sense? If B is a half, my period will double. Because my horizontal stretch will be actually by 2, right? So it does make sense. And then I get x pi over 2 units to the left, or pi over 6 units to the left, so plus pi over 6. And then plus. When you typed it in, did it work? With a positive cos, what do we look for? The closest what? Max, right? We look for the closest max. Yeah. Yeah. So for cos, you look for the positive positive cos, you look for the maximum away from the y-axis. Negative cos, you look for the minimum away from the y-axis. Sine, you have to draw the midline and instantly do the closest intersections and draw your arrows. Positive slope, positive sine, negative slope, negative sine, right? For this one, these are just taken right from your textbook. Write the equation of the sine function, so y equals amplitude of 2/3 sine. B, the period's 540. So B is going to be 360 divided by 540 degrees. What do I get? You take a 6 out of both, get 6 over 9, 3, 2 out of 3, 2/3. Oh yeah, I get 18 as well. So I get 2/3, which means I'm actually horizontally stretching by 3 over 2 or 1.5, right? If 360 is 1 full, 1.5 by 40, that makes sense. Bracket x, no phase shift. I'm really extra bracketing there. I didn't need those middle brackets. I just, yeah, really wanted to. And then 5 down. So you could have just went 2/3 x. So this isn't crazy if your transformations are good, right? Yeah.
How do you know if there's no phase shift?
How do you know if there isn't? It depends on the graph. So if in this case it's a positive sine, then if I drew my midline and the intersection point positive, they should be on the y-axis. So it's a positive cos, the maximum's on the y-axis. When it's a negative cos, the minimum's on the y-axis. When it's a positive sine, where they intersect and slope up is on the y-axis. If it's a negative sign where they slope and intersect going down, it's on the y-axis. So let's check this one out. So it's 2/3 sine. I need to be in degree mode. 2/3 sine, 2/3 x. And then what was it at the end, sorry? Minus 5. So I'm going to go zoom, trig. Hope to see something. So it starts at the amplitude's what? 2/3, and it starts at the midline at -5, right? -5 plus 2/3 doesn't get me the -4, does it? So I need to make my window -4 is too low, so I'm going to go -4 for my max. My minimum I'm going to make be -6. I'll do 7, just so it's a little lower, a little higher. And you can actually see it, right? Now I want to put my midline in, because I'm checking a sine graph, right? My midline's at -5, because it's whatever my d is. There's my midline. This is on the way up. These are on the way down, right? So my intersection and on the way up is right on there, so there's no horizontal translation. Does that make sense? So you have to draw your midline, and I instantly draw my midline if it's a sign, and I instantly do my little intersection points, because that like draws my eye to those, so I get my C's right. Okay? And if I have an option, I'm picking coast most often, because I can look for the absolute I can look for the maximum, how far away it is, or the minimum. But in this case, it would be better to actually pick sign, because the midline and the way up isn't right on the y-axis. I'm going to find a C value. So sometimes I would pick sign myself, because they give me no horizontal phase shift too. Okay? So we're going to go to our notes. We're going to go to the word problems. So, last we go over in trig for chapter 5, and we have to do a little tan thing, which we're going to caveat off tomorrow. We look at tan graphs very minimally. It's mainly sine and cos, and no word problems with tans either. So I just talk about them at the very end. So, the height of a rider on a Ferris wheel is given by the function h of t 10 sine pi over 30 t minus 15 plus 12. This is something you need to know. Word problems. Equal radian mode. Always. They don't make sense in degrees. That's why radian mode comes in effect. Word problems equals radian mode. So somebody will call me over the test and they'll be like, what mode is this in? And it's a word problem. Radian. There's no other option. Okay? So it's Ferris wheel, h of t equals 10 sine pi over 30 t minus 15 plus 12, where h of t is the height of the rider after t seconds after the rider gets on. I'm not answering any questions. When I get a word problem, I'm going to immediately tell all the stuff about it. Okay? What does the a in that word problem, or the a in that equation mean? This is my a. This is my B, this is my C, this is my D. What the heck do they all give me? What does my A give me?
Amplitude.
My amplitude. It just happens to be the absolute value of it, right? So it's the absolute value of 10, which is still 10. That didn't change. Okay, what else does it give me? What does the B give me? The period. So period equals 2 pi divided by b, never to put 360 because it's a word problem and they have to be in radian mode. So it's going to be 2 pi divided by pi over 30. Why did I write these sideways? Because I would end up having a fraction in my denominator or a fraction in my numerator. If I have a fraction in my numerator or a fraction in my denominator, I write them sideways because I'm going to have to flip and multiply, right? So I'm going to get 2 pi times 30 over pi, which is 60. So this thing repeats itself every 60 what? Seconds. What does the C give me? The phase shift. So I know this thing starts 15 to the right. I'm not sure if that's going to help me. What it's going to do, we'll see. This is a sine graph, right? So it's saying I'm meeting it at the very middle at 15. We know that, right? That's what I know. The horizontal, it's going to take me to get to the very middle of this 15 seconds. Correct? 15, right? What does my D give me? What does the D give you? Mid what? I'm not giving you the last two letters. You have to say the word.
Midline.
Midline. So this one has a midline at 12. 12. They didn't give units. That's nice. 12 meters. We're going to say is the height in meters. It's a very large Ferris wheel. It's not very large, but it's not a teeny tiny one. It's not a Lego Ferris wheel, let's just say. Okay? Now, on a circle, what the heck do those things actually represent? So on a graph, They represent amplitude, midline, period, etc., right? Okay. The amplitude would be half the distance from min to max divided by 2, correct? So the whole distance from min to max would be how many meters? 20, right? So we know that this wheel is from min to max 20. What's min to max on a wheel? The diameter. So we know the radius is 10. The radius equals amplitude equals 10. And we know the diameter, 10 meters, equals 20 meters. So actually, amplitude and radius are the same thing on a word problem, right? It's half the distance. It's the distance from the middle to the top or the middle to the bottom, which is the radius. Period. Period's how long it takes to repeat itself. So a normal period of a sine graph is 360 because that's a whole wheel, right? What's the period of this represent? The 60 seconds. What does that mean? Yeah. Yeah, one full revolution. So a period on a circle in a word problem is one revolution. So this Ferris wheel revolves one revolution every 60 seconds. It takes 1 minute to go around, right? Midline. Midline on a graph is the very middle of the graph, correct? So instead of looking at a graph like this, and this would be my midline, that's still representative of a circle, right? It's just a circle over time, correct? So what would the midline represent on a Ferris wheel? This is the minimum, this is the maximum, this is the midline. What could it represent? Yeah. Nope. Middle of the circle. It represents the center of the circle. Right? If it's the midline, it's the middle, which means it's the center of the circle. So the midline is just your center of your circle. So let's draw our circle out first with what we know. Not the actual sideways trig graph, just the circle. And what I do with my Ferris wheel is I split it into 4 always. Or any circle shape I get. So I'm going to have a coordinate here, a coordinate here, a coordinate here, a coordinate here. Because this is where I get on, right? And I ride up the Ferris wheel. I don't know, I always do it counterclockwise. It's an addiction. If you want to do it clockwise, it's totally fine. I just do it that way. So what is the center at? What height? 12, right? Now, height is y, correct? Height is y. We're going to get coordinates at each of these spots. So this one, I have a height of 12 meters. Also here I have a height of 12 meters. Why am I squishing it? I can just move over. How do I find the maximum? Anyone know? What information did they give me that can help me with maximum? Yeah. D plus the amplitude, because the amplitude is what? Radius, and the D is what? The middle of the circle, isn't it? So my amplitude is 10 meters. So what am I going to max out at? 22 meters, correct? And I'm going to min out at 2 meters. And why does that work? Because D plus amplitude, D minus amplitude, right? D is that middle, the center of the circle, and I'm taking the amplitude off and taking the amplitude on, taking the amplitude on. So I'm going to write over here. I'm going to go max equals D, which is 12, plus amplitude, which is 10, which is 22 meters. And the minimum equals 12 minus 10, which is 2. We agree? Now we can actually sketch this out, but we need points, right? We have y's, we don't have x's, do we? So we know that we're going to start at 0 seconds is what the Ferris wheel is going to start at. And what does it end at? How long does it take to go around? 60. So I have 2 of them. 2 of 5 points. How do I go about getting the other ones? How many pieces did I split this circle into? 4. So if I just go 60 divided by 4, it's 15 seconds. Every 15 seconds, I'm going to hit another quarter of my circle, right? So it's going to be at 15 seconds, 30 seconds, 45 seconds. And I know I'm right because I get back down to 60. Like it just reaffirms that I didn't make an oopsie. Does that make sense? We can actually sketch this. I can go straight up with this one. I'm going to make it max, like, look. This is going to be 2. This is 12. Here's 22. This is height in meters. Why am I showing you how to sketch this? Because I don't know what the written response could be. Right? They could make you sketch it. So you need to know everything backwards and forwards and not just the short ways. Then along here I have time. So this is time in seconds. 5, 0, 15, 30, 45, 60. Could I draw more? Will it keep going? Yep, 75, 90, 105, right? 120, and I could just keep going. Because sinusoidal graphs and cosine graphs are periodic functions. They just keep going. Would I go to the left on this question? Would I do any negatives for x's? Does it make sense to do negative? No, because what is our x values in? Time. It's in seconds. Can we go negative time? No. So now we can plot our points. We have 0 and 2. We have 15 and 12. We have 30 and 22. We have 45 and 12. 60 and 2. And we round it. It doesn't look like a pointy mountain. It looks like a nice rolling hill. Okay? Not a pointy mountain, a rolling hill. So how long, now we can answer any questions we want. We can even make equations at this point. We have everything we need. How long after the wheel is at its lowest point does it reach its highest point? How long, when we start at its lowest point, does it take to reach its highest point? 30 seconds. Did I have to draw this out to know that? No, it takes 60 to go around the whole way. Half of it is 30. But does it make it easier when you can actually visualize it? Yeah. You actually feel reaffirmed that you're picking the right numbers, not, I think it divided by 2 when I put that, right? So how long after it reaches its first point? 30 seconds. How long does it take the Ferris wheel to make one revolution? Yeah, good typing, Lepp. One revolution. How long does it take to do one revolution? Yeah, 60 seconds. No. D, during 1 minute of the ride, boom, 1 minute of the ride. That's that. 60 seconds is 1 minute. At what times after the rider gets on the wheel is it at a height of 20 meters? Row. That would be a full guesstimation at this point, right? Would we be guesstimating? 20 meters, I don't know, somewhere in here. So I'm going to get 2. I'm going to get this one and this one, which I could guesstimate they are. So when you're actually asked something like that, you have to come up with the equation. What equation would be the easiest one to make from this one? Positive sign, positive cos, or negative cos? Look at the y-axis always. Yeah, Hallie?
I guess it's the equation or the fact was originally given.
Yeah. Could we actually make an equation too? Was the one they picked the easiest? Did they pick the easiest one? No, they didn't. What would have been the easiest one? Negative cos. Why would it have been easiest? Because it's on minimums on my y-axis. We can absolutely use what they gave us though, right? Absolutely. But they didn't pick the easiest one. They picked one that's harder to type in a calculator, didn't they? Okay, so we can use the one they gave us. It should already be in our calculator. Do you have it in your calculator? If not, type it in. Callie, can you tell me what it is?
Like the equation.
Yeah.
N sign. Pi over 3. X minus 15. And plus 12.
Now, I'm going to press graph. It's going to be wild. First off, nothing's showing up for 2 reasons. My window sucks. And also, I'm in degree mode. I think I'm still in degree mode. Yeah. So it ain't happening. So you'll call me over and you'll be like, Lepp, I figured out the minimum, I figured out the maximum, I figured out the period, I even filled it in. I'm like, all good and everything. And I'm just like, I'm in the wrong mode, but I can't tell you. So you're just going to sit there and cry a little bit. Remember, word problems must be in radian mode, right? So I press graph, it's still going to be crappy. Ah! Why is it still crappy? What is my minimum? We figured it out already. What was the minimum? 2. So I'm going to make my y minimum, first off, it's still in degrees, but 0. My y maximum, what did it get to? It got to 22. So I'll make it 24 because I like seeing a little above below. I'm going to make it go up by 2 so I can see little ticks because I like seeing them as well. My x min times 0. When did it repeat itself? Every 60, correct? And it wants it on the first 60. Could I do 120 so I could see 2 of them? Sure, but do I want the answers only in the first 60? Yeah, so I'm not going to go more than 60 because I want to keep it in there. My x scale I'm going to make be, what was it, 15? Sure. Graph. Ah, it looks so much prettier when my window actually matches what the heck I just found, right? Okay, I want in the first 20. So when they give you y, which they did, they gave me y, which is 20 meters, correct? I'm going to go to my y2, and I'm going to put in 20. And I'm going to press graph. Now what can I do? Yeah, intersection. Second, trace, 5. So if they ever give you y, you can put it into your y2. Enter, enter, enter. So 23, we'll say 24, 23.9 seconds. T equals, and second trace 5. People will just hit enter, enter, enter again, and they call me over and they're like, it doesn't work. You're going to keep finding the same intersection unless you move to the other one, right? So you can take the path least traveled and follow the top, or I didn't know this in high school, and I would literally follow whatever it was on and just do it. If you arrow up or down, it bumps onto the other line and it can go faster. That one wasn't a big deal because there wasn't a huge difference, but sometimes you'll follow the entire sinusoidal graph like this, and you could just pop onto the linear one and just slide across. Which no one told me that in high school. I was just like, for 20 years. I'm like, come on, calculator, I've got time for this. I just slid right onto that straight line. Probably taught it and didn't listen. That's probably what happened. I don't know. 36.1. So even though they gave me an equation, I pulled information from it to sketch the equation because they don't always give me an equation. Sometimes they'll just tell me the amplitude like the radius is this, the center of the circle is this, it takes this long to repeat itself, and I have to come up with the equation. Okay? Which could be like this one. So the first one I gave you, a Ferris wheel question with an equation, correct? This time I'm giving you information about a Ferris wheel, no equation. So I'm still going to set it up the same. Still going to split it into 4. Whoa, that didn't happen. Still going to split it into 4. And there might be a base, I don't know. Sometimes there's not a base because you literally like step into like a little balloon, you know, like the Ferris wheels that look like a balloon. You step into it at ground level and it just travels you around. Sometimes they go below. So here we have a Ferris wheel has a radius of 10. What on here represents 10? This and this. What is 10? What is a radius in trig? Amplitude. So I know my A equals plus or minus 10. Right? It rotates every 40 seconds. What is a rotation? One rotation in trig. Period. So sometimes they'll say it rotates every 2 times every 80 seconds. So you can divide it by 2 and say, oh, it rotates every 40 seconds. Sometimes that's trickery, right? That's the harder one when they say it rotates every 3 times every 120. Okay, divide by 3, 40 seconds. Okay? So we know the period equals 40. We know B then equals 2 pi divided by 40, which is pi over 20. Like I said, people will call me over and be like, I don't know if I should use 2 pi or 360. It's a word problem. You have to use 2 pi. Not an option. Word problems are 80. Passengers get on at the bottom. That's good. Like set them on somewhere else. Awesome. Which is 1 meter above the ground. So what does that give me? Nope. My minimum. My minimum is 1. So I know down here, I know I'm starting at 0 seconds and at 1 meter, right? I also know I'm ending here at 40 seconds and 1 meter. We agree? What's my maximum at? So I'll go in here and I'll put a 1 as well so people remember there's a 1 down there. So my maximum is actually at what? 21. Something in 21. What's my midline at? 11. So people will tell me 20 and 10 here, but remember we have 1 to get off the ground. How do I get my time? How do I get my times on those coordinates? What do I do? Remember? Take the period divided by 4. So 40 seconds divided by 4, they're going to happen every 10 seconds, correct? So I'm going to go 0, 10 seconds. If you want to go clockwise, please do it. I don't know. I just do it counterclockwise. It's just how I roll. 20 seconds, 30 seconds, 40 seconds. So that didn't take us much to get our times. If you don't sketch it, there's a good chance you're going to tell me this happens at 10 meters and 20 meters. It's just going to happen. So that's why I do the sketch so I don't mess up my midline. So I know my midline is at y equals 11, which means my d value is at 11. So I have my A, I have my B, and I have my D, don't I? Let's do a little sketch. So here would be 1 meter, 11 meters, 22, 21 meters. This is height in meters. I don't know why I put the M's. My goodness. And this is time in seconds. I have 0. I have 10, 20, 30, 40. Sometimes they'll say, can you please sketch it for 2 full revolutions? Then I'd have to go to 80, right? You have to really read what they want you to do. So I'm at 0, 1, 10, 11, 20, 21, 30, 11, 40, and 1. Remember, I don't want to see a peaked mountain. I want to see a nice rolling hill. Write an equation that expresses the height of the function as time elapsed. What equation would I pick if I had a choice for this one? Negative cos y. The minimum's on the y-axis, so I'm not going to have a c. So if I have a choice, I'm going to go y equals negative, what was my a again? 10. Cos, what was my b again? Pi over 20. Bracket. I don't need a bracket. Why don't I need a bracket? I don't have a horizontal phase shift. And then plus 11 is my b. Right? We're going to go through, though, and do the other ones just in case. So, I'm going to tell you right now, watch this. Here's my midline. So if I actually do these coordinates on this circle, I have every single horizontal phase shift, just so you know. This is on the way up. So that's my horizontal phase shift for a positive sign. This is maximum. Oops, that's a little off. Let's pretend that's funny. So that's the horizontal phase shift for positive cos. And then this would be the horizontal phase shift for what? For a negative sign, because it's on the downward slope, right? You actually have all the C values. Why do I have that negative one? So if you sketch the circle, you actually have every C. So they could ask you to find a cos equation where a is less than 0, which would be fast. Or they could say determine the cos equation where a is greater than 0. If that's the case, we're going to get plus 10 cos pi over 20 x, and now I go to this one, minus 20 plus 11. Or they could say determine the sine equation with a positive. So I'm going to go 10 sine pi over 20 x, positive one's 10, x minus 10 plus 11. Or they could say determine the sine function where a is less than 0. So I get negative 10 sine pi over 20 x minus 30 plus 11. Do you see how drawing the circle you actually have all your C values? Yeah.
Did you do x plus 10?
Yes. On the opposite way. Yeah, you could do plus 10 because it would be symmetrical on the other side. Yep, totally. Like I said, if I have a choice, it would be the negative cos, because boom, I don't have to put a C. Find the height above the ground after 15 seconds. So they gave me t or x, right? I can just plug it in. I can go y equals, if they give me y, I have to put in y2, can find out where they intersect, right? If they give me x, I can literally plug it in. I'm going to plug it into the negative cos equation. I just type it into my main screen. In what mode? Radian, so pressing the button cos, right? So type that one in. Did anyone get an answer? Anyone type it in? 18.1? What units? And if this was a diploma question or a unit test, you'd write the height above the ground after 15 seconds is 18.1 meters. You would write a sentence, always. Right? Written response sentences. D gives us the height this time. If it gives us the height, what do we have to do? Put it into Y2. Find out where they intersect. Or what it was. I divide by 20. So I can quickly do my mins and maxes as well. My max would be 11 plus 10, which is 21. My min would be 11 minus 10, which is 1, right? Remember, you can still do D plus amp, D minus amp. It's a very good formula to remember for anything. So I'm going to go from 0 to 22. Well, it still works. So I get 12.61. If I want, I can go to my main screen. I can go second, quit, and go X, enter, and they'll put it down there for me. So that when I go back, I can try again. Second, trace 5. Enter, enter, enter. Now I got a new one, so I can go second, quit, get out of the mode, X, enter. And then I have both of them on my main screen. And then I can go back and chart that down the actual answers. So whenever you get a solution, you can go X, enter on your main screen, they'll put it there, or Y. So alpha 1, and it will put my Y there, which is 15, right? There you find solutions for 1. So 12.6 and 27.4. I don't remember, was it 23.4? 27.4? Wow. Once again, you'd say find the time when the height is 15 meters above the ground. The times where the height is 15 meters above the ground is 12.6 seconds, 27.4 seconds. This would also have to be specified, like in the first 40 seconds. If they said in 2 revolutions, we would actually have to go here, go to our window, make this be 80. And give an L4. Or they might say, determine the height, the time that the person reaches 15 meters in the second revolution. So I would only give these 2. Right? So we have to really read thoroughly. Okay, your homework. All we have left, yeah, English hasn't changed, good to know. All we have left is a little tiny piece of tan tomorrow, and then we're going to go through that booklet. So we have to make sure we're done it, right? That booklet, the review for chapter 4. You know what I'm talking about? That one. After tomorrow, we're halfway done the course. We've done 5 units, we have 5 left. We have chapter 6, which is trick 2, exponents and laws, which is 7 and 8, radicals and rationals. That's it. 9 and 2. Chapters 9 and 2. Still 11 units. We must be over half. We've done transformations. We've done polynomials. Chapter 4, Chapter 5. Terms. Oh, radicals, rationals, and operations we count together, that's why. We're not technically done half, but radicals, rationals, and operations are short units, like really short. So we're half, timeline-wise. And we're literally halfway to Christmas, so there we go. So your questions, are... Oh, it's so bad. Page 251, 6 and 7. And then page 276, 9, 11, 19, 20.